In this video, we're going to introduce a brand new concept called methods overload, comparing it with what's called method override. Both are important concepts in OOP, not just for Java, but other languages. Both overload and override serve different purposes. We have two examples, code snippets. On the right side, we have method overload. On the left side, we have overrides. Let's look at this class, test. Both has a main console, which invokes several classes. On the right side, we have class B and class A, where A extends B. So it goes like this. B is the parent class, and A is the child class. Same thing over here, where A extends B. So B is the parent class, A is the subclass. We already know method overrides in the prior examples. This is when your subclass overrides the parent methods. In this case, method overriding occurs when a subclass provides a specific implementation for a method that is already defined in the superclass, such as method P. Both super and subclass have the same exact method signatures bearing accessibility, the same method name, and the same parameters list. The overriding method must have the same exact name, parameters list, return types as the method in the superclass. So this example, method P, illustrates method overrides. Method overriding is used to implement what's called polymorphism. This is a concept that we will explore further, where the subclass can provide its own behavior while still using the common interface defined by the superclass. So this P method in the superclass is the template or common interface. Overriding methods are resolved at runtime based on the actual type of the object, allowing dynamic dispatch. Previously, we talked about the lifecycle of your code going from compile time into runtime. Compile time involves compiling code into its bytecode. And this bytecode is interpreted and run on what's called Java Virtual Machine at runtime. The behavior assumption of A assuming the behavior of P from B happens at runtime. This is really the premise behind polymorphism, or the dynamic shaping of the object behaviors that we alluded to. Let's look at this method overload. In comparison, we have the same console application. We have the same inheritance structures where A extends B. However, we have a different method in class A. Method overloading refers to defining multiple methods in the same class with the same name, but different parameters lists, namely the number of parameters, the type of parameters, and the order of parameters. As you can see, integer I is completely different from double I, even though all the other method signatures look the same, including the accessibility modifier plus the name of the method and the return type, the difference being parameters list. Sometimes their return type may be different too, although the method names are exactly the same. This is an example of method overload. The overloaded methods such as this are resolved at compile time, namely here. This is based on the number and type of arguments passed to the methods. So your compiler at compile time determines this method as what is inside the superclass. Basically, method overloading is used to provide multiple ways to call a methods with different parameters combinations, making the code more flexible and readable. The resolution of your method overload happens at compile time, whereas method overrides happens at runtime. This is a big difference between the two. Let's look at some code examples to illustrate both. This is an example of an inherited structure involving two classes, where animal is the superclass, dog, which is the subclass, inherits from animal. So in Java, we use dog extends animal. Both classes have their own default constructor. Dog has a super constructor invocation. Since super does not have any arguments in it, even if you don't supply line 9, your program will supply it to you at compile time. So by creating an instance of dog, it also creates an instance of an animal by way of super constructor call. Method overrides. Let's create a sound method in the superclass and system out print line something. Animal makes a sound. Let's override that method in the doc class. In Java, we can use the override keywords. This override keyword is also called annotation, which is used to indicate that a method in a subclass is overriding a method in its superclass. This annotation is optional, but it helps improve code readability and ensures that the method is indeed overriding a method from the superclass. We're going to make a method that looks exactly the same as what you see in the animal class called sound. We will system out println doc makes a sound. This is an example of method overrides where doc sound method overrides the behavior of its animal methods. You can also opt in to invoke super's sound method like this, perhaps with a space between the two. Your doc class would have access to its parent's sound method as well. The reason why we can do this is by default, methods in interfaces or in the superclass, they are implicitly public, which means you can do super.sound in the subclass to invoke this public method. As best practices, it's best to have a public keywords in front of it or any SSR modifier to make your code a lot more readable than what it looks like right now without this public. In general, all of the default methods are accessible from any class that implements the interface or this class, whether they are in the same package or in a different package. A small mention of this override annotation. Developers like to use this override, not because it makes the code readable, but it also serves as a compile time check. Your Java compiler actually verifies that the method marks with override is indeed overriding a method from a superclass. Remember, method override is a runtime behavior. There's no compile time check. So by having this annotations in place actually forces your Java compiler to validate this. If there's a mistake in the method signature, for example, misspelling or wrong parameter type, the compiler will generate an error alerting the developer to the issue. This significantly mitigates any potential bugs. So I'll say this override annotation is a very useful and helpful tools in Java for ensuring that method overriding is done properly, correctly, and in addition to improving code maintainability. Let's look at this other compile time behavior called method overload using the same example. In the subclass, let's just add a few methods. Let's say this sound method having a different return type, but the same name as the overwritten methods. For brevity, let's just return -1 for the sake of our illustration. We also create another method sound, this time with the same return type as the overwritten methods, but different parameters list. For kicks, let's just create some dummy parameters. Both sound methods 1 and 2, these are overloaded methods of the original sound method in the superclass. The reason why they overload it and not override is because they're not being overridden. They're different methods, but they're overloaded in the sense that they all have the same method name, sound. Both 1 and 2 bears complete different method signatures with a different return type and or a param list. Method overloading refers to defining multiple methods in the same class with the same name, but different parameters lists, like the number of parameters, the types of parameters, or order of them. They may also have different return types, rendering both 1 and 2 overloaded method of the original sound. As we mentioned before, overloaded methods are resolved at compile time. Your compiler checks for the existence of these overloaded methods, ensuring that they could be invoked, loaded in memory, and they are different than the original one. There is no properties or behavior assumptions as you would in an overridden method through inheritance. Method overloading is used to provide multiple ways to call a method with different parameters combinations, making the code more flexible and readable. A lot of times we define a group of these methods when they assume similar functionalities. Like these methods, even though they are overloaded of the original, their functionality is to make a sound, maybe in a different way, having a different logic. Hopefully these examples illustrate clear pictures of the differences between method overrides versus method overload in object-oriented programming.